Can you see the slide movements?
Yes, ma'am.
Okay. So in the last class, we have dealt with what we call it as the evaluation of the expression. Okay, so work on more number of evaluation of expression. Okay, so I have already sent you the question papers. You open the question paper, you check it out what kind of questions that are asked on the module 1, because evaluation of expression was the last part of the module 1 actually. Okay, so now, so I at least request everybody. I think I have uploaded nearly 4 question papers. So 18 scheme question paper. Okay, so now just go through them and try to solve the questions that are asked. Okay, so if you are unable to find any answers there, okay, so you can ask those things in the, okay, maybe in the class or maybe personal chat, using personal chat. Right? Okay, so now as a part of the what we call it as problem solving skills, we have started with, you already know, the algorithms. We have studied variety of algorithms in the laboratory, something like the sequential algorithms, and then we went for the conditional algorithms, then we went for the iterational algorithms or looping algorithms, right? Okay, so after that we went for the second problem solving method called as the flowchart. Okay, so now flowchart is nothing but just translation of the algorithm into a pictorial representation or a pictorial presentation called as the flowchart. Again, you have the same 3 kind of things that are found in the flowchart also. You have sequential flowchart, you have the conditional flowchart, and you have what we call it as the iterational flowcharts. Okay, just you have to translate the algorithm. All right. Okay, so in the last class we have studied the symbols also, in the lab. Along with that, we have taken up the example for the sequential flowchart also. Is that correct? So this is what we people have studied. Hello? Hello? Hello, students? Hello? Hello?
Yes, ma'am.
Okay. So today we'll talk something related to the flowcharts related to the conditional one. Okay, this is again the sequential one that we have studied already. So today we'll go ahead with what we call it as the conditional algorithm. Sorry, not conditional algorithm. This is conditional flowchart. All right. Okay. So to find the maximum of 2 numbers, how do you find the maximum of 2 numbers? Can you tell me the algorithm for the same stuff? Hello. I need answers from you all. So you are supposed to find find the maximum of 2 numbers. Right? How do you write the algorithm for this?
First step, start.
Okay, step 1, start.
Second step, read the 2 numbers. Second step, declare variables.
Read. So here in algorithms, we never declare any algorithms. Variables. We don't have that concept. If initialization has to be done there, we'll be doing the initialization. But there is no concept of declaring because we are not intimating it to anybody. These algorithms are just for our sake. For program, we have to declare. So that structure you have to follow, whatever C structure that I have given there. Yes. Read.
2 numbers.
The numbers.
2 numbers. Okay. X and Y. Okay. Next, third step.
Condition operation map.
How do I write?
If x is greater than 1,
x is greater than y.
Print output x is greater.
X is larger or greater. Okay.
Else y is greater.
Else, very good. Print y is greater. So this is how we're supposed to write the algorithm. Last step is
Stop.
Stop. Right?
Stop.
So for the same thing, I have to I'll draw the flow chart. Right? So you already know this algorithm. So I'll try to draw the flow chart for the same. Right? So first one is
Oval.
oval shape. Start.
Parallelogram.
Parallelogram. Read. X comma Y. Next.
Rectangle. Sorry,
I have to
diamond.
use rhombus. Yeah,
Diamond.
rhombus because I have to check for the condition now. So how do I write the condition? Is X greater than Y? Question mark. This is how you are supposed to write inside the rhombus. Okay. So output of this is two outcomes for this. One is true, another one is false. If it is true,
Print. X is large.
print X larger.
X is large.
Correct? Else, false.
Y is great.
Print Y is larger.
Large.
Okay. Then I'm going to stop. So stop inside the oval. So I'll just joining these two. So look at this. Here it purely depends on what value you are going to give for X and Y. So if I read X is equal to 8 and Y is equal to something like 2. It is checking for a condition is 8 is greater than 2 or what? Is it true or false? Is 8 is greater than 2?
Yes, ma'am.
True.
Yes, ma'am. True.
If it is true, then where should I go?
X.
So it is going to print 8 is X is 8 here. 8 is larger and it is going to stop the algorithm. If I give the reverse of this number, instead of this, if I write it as 2, if I write Y as 8 there, then it is checking for 2 is greater than 8 or what? Is 2 is greater than Y? 8?
False.
False. If it is
False.
false, then it is going to print
Y.
Y, that is
Second.
8 is larger and it is going to stop the algorithm. So at any given instant of a time, the workflow is either like this or like this, not on both the lines. This is what I wanted to convey. So either it can be like this or it can be like this, not on both the lines. Clear, student?
Yes, ma'am.
Yes, ma'am.
Any doubt regarding this? Do you have any doubts regarding this?
No, ma'am.
And I'll be printing A is greater if it is true, right? If it is true, then it is going to print A is largest. Okay, if this is false, then it is going to print B is maximum among these two numbers, right? So this is a flowchart associated with that. All right. So I'll go for the next one. Find whether the number is odd or even. You already know the algorithm. Okay, so now can you tell me how to draw the flowchart for the same? Hello.
Get the oval one.
Okay. So I'll write the oval one. In that I'll write start. Next.
Take a input.
Right. Read n. So this number, I have to check whether this number is
Odd or even.
even. Right. Next. What is the condition that I am supposed to apply for this?
Modulus of n.
Right. So I'll write that. Is n modulus 2. Is it okay? Equal to 0
Yes.
question mark. Is it true or what? This is what I am asking for. The condition I am writing is n mod 2 equal to 0 question mark. This is going to come under the what we call it as this particular rhombus. Is this okay?
Yes, ma'am.
Yes, ma'am.
Okay. So it has got two outcomes. So one is true, another one is false. So you can write it anywhere. So either you take this here or take this here. Okay, but it has got two outputs. One is true, another one is false. So if it is true, n mod 2 is equal to 0, then
Even.
print
Even.
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 Okay. If it is false,
Print odd.
Odd.
print odd. Is it okay?
Yes, ma'am.
Okay, then I am going to join this. So what is the last statement for this?
Stop.
Stop. Is it okay? So
Yes,
this
ma'am.
is the algorithm for the finding the, this is a flow chart for the whether the given number is odd or even. So any doubt regarding this, students? I'm just translating the algorithm into flow chart. I'm not doing anything much. I've already taught these things. I'm just translating that algorithm into flow chart. So any doubt?
No, ma'am.
So any doubts you people can ask me. No issue. So look at the diagram. So you have a start there. Okay. Then you have to input a number there. You are checking whether that number is equal number mod 2 equal to 0. Write a question mark there. If it is yes, then you are displaying it's a even number. If it is no, then you are displaying it is a odd number. So at any given instant of a time, either the flow will be like this or flow will be like this. It cannot be both, because the red number cannot be both even and odd. Either it can be even or it can be odd. Correct, no?
Yes, ma'am.
Yes. Okay. So now if I read number as something like 4 there, then so it is, I'm reading it as 4 here. So it is 4 mod 2 equal to 0, because 4 mod 2 remainder is 0 there. Okay. So this condition is true there. If this condition is true, I am coming here and it is printing the number is even, and I am ending the algorithm. If instead of this, if I read this as something like 9 here, so then, so 9 mod 2 is equal to 0. No, it is not equal to 0. Then it is yielding me false result. That time I'm going to print it is an odd number and I'm going to end the algorithm. Is that okay?
Yes, ma'am.
So any
Yes,
doubt
ma'am.
regarding this?
No, ma'am.
Okay. So let's proceed with the next. Okay. Find the sum of the first n natural numbers. Okay, you already know the algorithm there, right? Do you know the algorithm for finding the first natural numbers?
Yes, ma'am.
Yes. Okay. So first you are reading, you are initializing I is equal to 1. In this case, I have taken it as capital I. Then you have to initialize sum is equal to 0 there. And inside the loop, what are the two conditions that you are supposed to write?
Equal to
Little
I
louder.
less than n.
No, inside
I less
the
than.
condition, what are the two statements that are going to be repeated?
Sum plus I and I plus plus.
Very good. Sum is equal to sum plus I and I is equal to I plus So let me write capital I plus 1. So these are the two statements that are going to be repeated. What is the condition that you are placing for this?
I less than n.
I less than or equal to n. Correct? Capital N. Okay, it's in this case I have taken it as capital N. For this you have to read n there. So read n, check for this condition. Okay, capital I. Capital I is less than or equal to n there. If it is true, then I'm going to execute these two instructions. Once this condition becomes false, then I'm coming out of this. Okay, this is step 1, maybe, okay, step 2, step 3. Okay, maybe, okay, let me write. Start is 1, 2, 3, 4. All right, start. 4 and 5. So these two are included inside the while loop there. 6th step. What is 6th step? If it is false, what you are going to do?
Come out of the loop.
You are coming out of the loop and what you are
Display the sum.
printing? You are printing the sum.
Sum.
Correct? Right. And you are ending the loop. Algorithm there. Right? The same thing we have translated into what we call it as flowchart here. Start, initialize. So I is initialized to 1. So it's a rectangle which is doing the processing. We are assigning certain values means it's a processing task. Equation means processing. I equal to 1, sum is equal to 0 there. Now you are supposed to read the values. Correct? So I am reading how many natural numbers that I am supposed to read. Okay, if I write it as something like 5 there, so 5 natural numbers I have to generate and I have to add 5 natural numbers there. That's what is the meaning of that. So read n, then check for the condition is I is less than or equal to n or what. If it is true, then you do these two things, sum and I. So calculate or find the next natural number and find the summation of the previously generated natural numbers there. So this what you people have already studied. So that's why I'm not going in depth of that. Okay, I'm just translating the algorithm that you already know to flowchart here. If this is false, okay, then I'm printing the sum and I'm stopping the algorithm. Yes, any doubt regarding the writing of the algorithm? So look at this. This is very important. Loop has come out here. Okay, so if you look at this, so you have the loop. This is a loop. Okay, so I'll be in the loop. Okay, how many times till this condition is false? If this condition is true, then I'll be in the loop. Once this condition is false, I'm coming out of the loop. I'm quitting the loop. And there is no connection between this inside statement with the outside statement here. So this you have to remember. This is how I have shown with the algorithm also, flowchart also. If you are perfect with writing the algorithm, it's very easy to translate that into flowchart. Right? If you are very much clear with this algorithm, then writing the program is not a big issue at all for you all. If you know the syntaxes of the program there, the particular language there. So any doubt in this? You have any doubts, please feel free to ask. Hello? Hello, students? Hello? Do you have any doubts, students?
No, ma'am.
Okay. So I'll go ahead with the next. Find the factorial of a given number. You already know about the algorithm as well as algorithm. Okay, we are just translating that into program. Before that, one more time, we'll just go through the algorithm. So what are the two things that you have to have inside the looping statement? Any one of you? What are the two statements we should have inside the looping statement?
Condition and the increment statement.
Condition and increment statement we should have inside the looping statement.
Outside the
I'm asking you what should be inside the loop. Okay, which are the two statements that are going to be repeated there? You tell me those statements.
Factorial and I.
Okay, so fact is equal to fact into I. Okay, this is one stuff. Next one is I is equal to
I
I
plus
plus
I
one.
one.
plus 1.
I plus
Okay, these are the two statements that are coming under the repetition or looping statement. Correct? What is the condition that you are going to place? What is the condition?
I less than n.
I is less than or equal to n.
Okay, why I is less than or equal to n. This is a condition that you are going to write here. Correct? Is this okay?
Yes,
Is
ma'am.
this okay? Okay, what is n?
Yes, ma'am.
What is n?
Natural numbers.
Natural numbers.
Is it natural number? Check it out. What is n? Okay, instead of this, let me write it as capital N. What is capital N? What is n? You are going to find the factorial of a given number.
Factorial numbers.
So what is this n corresponds to?
Numbers.
What number?
Factorial numbers, ma'am.
Factorial of a given number.
Right. So you have to find a factorial of a number, no? Are you interested to find the factorial of a number or no? If I
Yes,
tell you
ma'am.
people to find the factorial of a number,
Yes, ma'am.
so what you are going to ask me? I tell you to find the factorial of a number. What you are going to ask me? You'll directly find the factorial.
No,
Number.
number first.
You'll ask me the number, no? So this n is that number. If you say 6, then you'll say 6 factorial. You'll find the 6 factorial. If I don't give this number, what you are going to find? Okay, you are supposed to find the factorial, but you don't know what is the value. Okay, what factorial I'm supposed to find? If you don't know, then what is the factorial that I'm supposed to find? Okay, so this n is talking about that. Clear? Is it okay? Right? Okay, so
Yes,
now what should be the value of fact? What is the value initialization of the factorial? I mean fact value.
1.
1. Okay,
1.
why it is 1? Why it is 1?
Because multiplicative inverse is 1.
Very good.
Multiplication with
Very good.
any number.
Okay, so that you have to remember. Okay, so it's a factorial. Okay, so this is fact. So this is initialized to 1 because it's a multiplicative inverse. And I've started with the first natural number because I said you whenever I'm finding the factorial, so I'm going in a reverse manner. So I'll be doing it as 1 into 2 into 3 into and so on up to capital N there. So instead of doing n into n minus 1 into n minus 2 into n minus 3, I'm doing it as 1 into 2 into 3 into 4 into up to capital N. So is there any change in doing like this?
No.
No. So that's why. So we went for this. I mean, something like this. We made the process easier. That's all. So these are the two steps that are repeated there. Okay. So now afterwards, if this condition has become true there, then false there, I am going to print this. Okay. So let me go through the flow chart here. So start. I am reading the value of n here. So whose factorial I am supposed to find, right? That is n. So I am initializing these two values. So this should be written inside the rectangle box there. Is okay. Is this is lesser than or equal to n? Then if it is true, then what I am supposed to do? So I am supposed to find a factorial of a number, and I am supposed to increment the value of I. And I'll be inside the loop here. I'll be inside the loop. So how many times this is going to be, these two statements will be repeated?
Unless the condition is false.
Very good.
I is less than or equal.
Right. Very good. Correct? Is it okay?
Yes, ma'am.
Okay. If the condition is false, what you are going to do?
Print fact.
Okay, you are coming out of the loop and printing the factorial value, and you are quitting the algorithm flowchart, or you are stopping the flowchart. Clear, student? Any doubt regarding this? Any doubt in drawing the flowcharts? Hello?
No, ma'am.
No, you can write either, you can draw a flowchart, or you can write the algorithm, no, for a given problem statement.
Yes, ma'am.
So you are able to do that. I hope, you people can do that. If you are given with a problem statement, I hope you are able to give the answers in the form of algorithms or in the form of flowcharts. Now, we never expect both, but in the final exams, they may expect both also. Right, but whenever you go ahead with the laboratory sessions, so we'll be asking you either the algorithms or flowchart, not both. Any one of these two you have to write before you write the programs there. Clear, students? Clear? If you have any doubts, you people can ask me. Simply if you keep quiet, so I don't know what to do. Understood? Understood? Say something. Have you understood? I have not taught anything extra. Okay, whatever algorithm I have taught to you people, I'm just translated that into flowchart. That's all I've done. And you have already studied these things in the laboratory, right? So I've just expanded the same thing, right? So that you people can solve some of the examples in the laboratory. Okay, I will be throwing you the problems. You people can solve it. Is it okay? Say something.
Okay, ma'am.
Okay. So let's go ahead with the pseudocode. Okay. Pseudocode, the meaning of pseudocode is, okay, so this is not the actual code, but it is very much similar to that of the program. Okay, so whichever program you people can write for any of the algorithms there. Okay, it is very much closer to the program. That's what I can convey. But it is not the code, it is not the program. Okay, it is not the code, it is not the program, but it is very much similar to that of the program. Right? That's why we call it as a pseudocode, very closer to the programs. Right? So how do we write these codes or a pseudocodes? Here we don't follow that step and all those things, what we have followed for the algorithms there. So we are not writing the start, we are not writing the step 1, step 2 followed by a colon and all those things. So in this case, simply we'll try to write the algorithm in the way we are interested to give the solution for the problem there. Okay, how can we write? So I'll just show it. It is left to the end users again. Okay, so now I've taken simple example here to swap two numbers using the temporary variable. So I'm interested to write the pseudocode for this. Okay, how do I write the pseudocode for this? So it's very simple. So I'll start with what we call it as reading a number, read two numbers. So I'll read it as two numbers as x and y. So after reading the numbers, so how do you do the swapping of a number using third variable?
To x.
So I'll take temporary variable, temp is equal to
X,
x, x equal to
Y.
Y,
y equal to
temporary variable.
temporary variable. Right, so in between if you wanted to print the values, so you people can print also. So print x equal to, x and y. So it's going to print whatever values are found inside the x and y there. Then you are doing the swapping there. So after doing the swapping, so what you are going to do, again you have to print x and y. And so this is the end of the algorithm or the pseudocode. So I have not written any step here, nothing like that. Okay, so this is very much similar to that of what we call it as this. Then how do I differentiate where program has started? For that usually people will use something called as begin. just to understand where the algorithm, where the pseudocode has started. So that's why they use, okay, begin and end. These are the stuffs that are coming under the begin and end there. Is it okay? Is this okay?
Yes.
So I've not done anything. I have not written step 1, step 2, step 3 and all those things. Okay, I already mentioned it is very much closer to that of the program there. Okay, that's why the name pseudocode. Okay, so usually pseudo means some students will say it's a false, something like it, dictionary meaning is that. Okay, but we say that it is very much closer to the program, but not the program. It is not the program, but very much closer to the program there.
Excuse me, ma'am.
Yeah.
Means in pseudocode we have to just write the fragment of program.
It's not fragment because I have not used the statements that we are supposed to use, because there are variety of syntaxes that are available in the particular languages. If you study C language, you have different syntaxes. Okay, if you study some other languages, you have different syntaxes. I'm not using those syntaxes inside this. Okay, so I've just used the normal stuff, something like read here, something like print here. So instead of print, you people can use display there. Okay, so here input, you can say it as input here. So you can write it as output. Okay, so now I'm not, but the other stuff, if you look at the other stuff, so these are very much similar to, there I'm going to replace the actual statement. Whatever syntaxes that are associated with that particular language, so I'll be writing those stuffs. Here I'm not following all the things that I have adopted for the uh, algorithm there. In algorithm, you already know. I've written step 1, start. Step 2, I've written something like read. Okay. Then I wrote something like step 3. Okay, so I've written so many things there. Step 4, step 5. Here I'm not following all those things. Okay, because these things, step 1, step 2 and all those things we are not using inside the programs also. Okay, that's why we wanted one simple technique that was very much closer to the languages there. So that's why they came up with this particular pseudocode there. Is it okay? Is it okay?
Yes.
Okay, look at this. The same thing, right? Okay, read and B. So because just I am writing this begin and end. Okay, because I wanted to know where my algorithm, my pseudocode has started and where it has ended. Okay, that's why we use begin and end for that. Okay, then I'm reading. Okay, before that you wanted to print, you print. Okay, then you swap the contents, then you again reprint that. So here you have different value for A and different value for B there. Clear, students? Hello?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Then to read the number and determine whether the number is even or odd. So can you try with this?
Yes, ma'am. First step,
Yeah.
begin.
Okay.
You can read the numbers.
Okay.
Read the
numbers
numbers.
I have to read. I read number.
Number, ma'am.
Okay.
Number,
I'll
only
read
one
N.
number.
Okay. Fine.
Okay. Condition
Logic.
If I have to apply
if n modulus
N
2 equals
is
to 0.
modulus of two equals to 0.
Okay.
Else,
Display n is even.
Display even.
N is even.
Okay. So
Else odd.
else
Display odd.
else display odd.
display. Okay. Then
Uh,
And
end.
end of
N
the pseudocode. Is it okay? Is this okay?
yes, ma'am.
yes, ma'am.
So this is very much, that's why I'm saying it's very much closer to a program. So this you can easily translate it into a program using any of the language. There is no issue. Right. So let me show you the code. Okay, pseudocode. Okay. Is it okay? There is no particular format for the pseudocode, but I am not following whatever things that are followed for the, usually we follow for the, what we call it as the algorithms there. Right? Okay, so this is all about the pseudocode. These are the 3 techniques that helps you to solve the problems. Right? So if any problem is given to you people, you should be able to, again and again I'm stressing you all, you should be able to, right, give the solution using these 3 techniques. Okay, so which one is suitable for you, you adopt that technique. I'm not forcing you, you have to write only algorithm, you have to write only flowchart, you have to write only pseudocode there. It is up to you people. You may adopt algorithm, or you may write the flowchart or draw the flowchart, or you may write the pseudocode. Okay, so use any one of these 3 techniques to give this solution. Okay, so whenever we come across the problem, the laboratory programs, okay, so I'll be showing you for some of the examples, I'll be giving you the flowchart. For some of the programs, I'll be giving you the algorithm. For some of the things, I'll be talking about the pseudocode, because I wanted to show variety in the things there. Okay, so I'll be showing all the things there, but I'll not be showing all the 3 for one program there. Okay, that you have to keep in your mind. I'll be writing the algorithm, or I'll be writing the flowchart, drawing the flowchart, or maybe the pseudocode there, but not 3 for one program there. Clear? Is it clear, students? Hello?
Yes, ma'am.
Okay.
Yes, ma'am.
So this is all about the pseudocode or the problem solving skills. So let's look into the next bit of it. Okay, so I'll start with the, what we call it as the second module, right? Okay, so where we'll be dealing with the input output statement. Now just tell me whether you are able to see the slides or no before I proceed with. Can you see the slide movement?
Yes, ma'am.
Okay. So in this chapter or in this module, we are going to talk about the input-output operations. Okay. Along with this, we'll be talking about the decision statements also. Along with decision statement, we'll be going out of the looping statements also. Right. So these are the 3 things that we are going to study under the module 2. I'll repeat my statement. In module 2, you are going to deal with the input-output operations, and we are going to talk about what we call it as a decision statements. We are going to talk about the looping statements. Okay, these are all the things that are coming under what we call it as the second module. Now we have started with our programming. Okay, you already know in the first module only I have told you the different types of operators that can be used inside the C language. I have taught you all the operators that are used in C language. Not only that, I have told you how can you translate the given mathematical expression into the C expression also. This is what we people have studied in the previous module there. Along with that, we have discussed something related to the variable declarations. Okay, how can we declare the variable, and how we people are able to even declare the constants also. Okay, this is what we have studied in the module 1. I hope you already, you already know about these things, you remember these things. So along with this, we studied the structure of C language also. Okay, can anybody tell me the structure of C language before we proceed with?
Yes, ma'am.
Can anybody tell the structure of C language?
First, documentation section.
Okay. So documentation section is optional. If you want, you people can use, otherwise leave it. Next.
Preprocessor directives.
Very good. It starts with hash include. Next.
Then global declaration.
So presently we are not playing with the global declarations and the function declaration there. So we'll not worry about those 2 stuffs right now.
Main function.
Main function.
In that main function, open braces.
Open. flower brace.
Then declaration part.
Very good. Declaration of the variable that are used inside this main function.
Executable part.
Executable statements. Very good.
Closing braces.
Closing braces. Very good. Okay. So these are the things. After this, you may write, okay, what we call it as the functions. Okay, but right now we are not playing with the user-defined functions. So this is important for us, right? First, you are thinking of going out of the documentation, then a linking section or the hash include section, followed by the main function. In this, you have two things. One is the declaration and the another one is the executable statements. So here we never followed the declaration kind of stuff whenever we write the algorithm or the flow chart, or we write the what we call it as pseudocode there. Okay, because these algorithms, flowcharts and pseudocode are meant for the end users. So this program is meant for the system here. So you have to mention this, okay, because it's a system which is going to create the memory to store the data there. So if you don't declare it, it is unable to create a variable where you people can store the data there. I hope I'm making it clear. So without declaration, you cannot use the variables inside your program there. If you don't declare it, it will say that unable to get the value for x, unable to get the value for y, something like that, unable to get the value for n. Because it does not know what is that n, x and y there. You have to declare it. You have to say it to the compiler. Now these are the three variables I am going to use inside my program. Okay, then it is going to create those variables. So this declaration plays very important role. So this was not found in case of these three things that you have to remember. This is very important fact that I am telling to you all, because you have always a confusion with the algorithm and the programs there. Because so you'll ask, madam, in algorithm we have not declared anything, we are simply written something like read n and okay, something like that. That is not true in case of writing the program here. You have to tell, okay, you have to declare n, then it is going to create a memory location in the name of n. Okay, that's why we have the variable declaration part inside the structure of C language. Is that clear, students? This is very important fact that I am dealing with. Is that clear? Hello?
Yes, ma'am.
Okay. Then you have executable statement. Okay, so whatever operation you wanted to carry out, so that should be part of this variable, executable statement. And one more thing I wanted to mention here, every statement that is written inside this particular main function must end with a semicolon. Every statement in C language ends with a semicolon, except few, which are not ending with semicolon. So that I'll be dealing with whenever I'm teaching those things. I'll repeat my statement. Every statement in C language ends with the semicolon. But few of them are not, never ends with the semicolon. What are those? I'll be teaching those things whenever I'm taking those syntaxes for teaching to you all. So if I take in this example, main never ends with a semicolon. Don't put semicolon in front of main. If you put a semicolon in front of this, and if you execute this program, nothing can be visualized, nothing can be seen, and even it won't throw you an error telling that you have put the semicolon in front of main. It just keep quiet. You won't be able to understand what has happened with your program also. Main is a function, and function is not ending by placing the semicolon in front of that. If you put a semicolon in front of this main, so this suggests the compiler that this is ended here. Main is ended. So it is not following, or it is not looking into the instruction that you have written for this main. Okay, so main never ends with a semicolon. By mistake also, by chance also, you are not supposed to end main with semicolon. If you end with semicolon, compiler never throws any error back to you people. Compiler never throws an error back to you people. Okay. So maximum students in the final exams, laboratory exams, fail only because of this. They forgot, they just put semicolon in front of main, and even though the program, whatever program they have written, that is correct also, they are unable to get the results. No errors, nothing, because they have put a semicolon in front of main there. So main is not at all executed there. Nothing can be visualized as a output there. I hope I'm making it clear. And maximum students will only fail because of that. They'll put semicolon in front because madam has told, put semicolon in front of every statement, C statement. So I'm saying that also. For few, we are not supposed to place the semicolon. Which are those? I took an example. In front of main, never place a semicolon. By mistake also, by chance also, we are not supposed to put semicolon. Clear? Clear, students?
Yes, ma'am.
This is very important fact. And I'll show you, if you want, I'll give you the list of the students who failed because of that. There are out of 100 students, 10 students will fail only because of that. And will not be there to say you what is the problem. Okay. We'll be just coming and checking your program. If your program is working, he'll give you the marks. Otherwise, he'll say, so it is not executing, you can go out of the lab. I hope I'm making it clear. This is very important fact that I'm telling to you all. So these are the two things that are coming under the parts of the input output devices. Now we are moving towards a C language. So you have two types of inputs. One is the unformatted IO statement or the IO functions, and you have the formatted input output functions here. First we'll look into the input out of unformatted input output statement, then we'll move towards the formatted one. Right? Okay, so formatted or unformatted input output statement means these are helping to read the data from the keyboard. So I'll repeat my statement, to read the data from the keyboard. Okay, so we are going ahead with the input statement. To display something on the output device, that is display device. Okay, so we are going ahead with the output statement. So input statement to read the data. From where you are reading? From keyboard. Okay, to read the data to your program. Okay, from the keyboard, we are going ahead with the input statement. To print or to display the output, because every time you said read n, read x comma y, from where I have to read those values? From input device, from keyboard I am going to read. For that we have the particular input statement that are coming under the formatted and unformatted input statement under C language. Okay, so similar to that, we wanted to display something on the output device. You already know. So we'll be saying display even, display odd, okay, display the sum. Okay, so now where should I display that? It has to be displayed on the screen there, right? So to display something on the output device, we go ahead with the output statement found inside the C language. We have again two types of output devices. One is formatted output device, another one is the unformatted output device. Sorry, output statement. Okay. To whenever you are playing with the input and output, the library file that you are supposed to include is stdio.h. This you have to remember. So this must be included. This is standard input output header file. Okay, if you don't include, if you directly write the program using the input output statement inside your C program, then it is not going to give any result. It will start throwing the error telling that printf is not declared or printf is not defined. Okay, scanf is not defined. Put character is not defined, something like that. I hope I'm making it clear. So this is very important. You have to include the header file. What header file is supporting the input output statement?
stdio.
Very good, stdio.h. So that's why you have to include this inside the inclusion section. Okay, hash include stdio.h. So after including this, then you write the statement related to the input output statement inside the program there. Is this okay? Is this okay, students?
Yes, ma'am.
Okay. So these are the unformatted input output statement. Okay, so these are unformatted. And please remember, these are purely meant for reading character. I'll repeat my statement. These are all statements are helping us to read character or set of characters. Other than character, it never reads any other values. These never reads or writes, prints the integer numbers. These never reads the floating point values. Only characters. I hope I'm making it clear. So unformatted input output statements are helping us to read only the character or set of characters. It is helping us to print only the character or set of characters. So these never play with the integer or a floating point values. Only C, character. Is it okay? Is this okay, students?
Yes, ma'am.
Okay, so now the details of this, and I'll take one example on this. I'll show you, working of that in the upcoming class. So do you have any doubts regarding the other part that we have discussed in today's class? Before I close my session, okay, do you have any doubts?
No, ma'am.
Hello?